Okay, good morning class. So today we're looking at Euclidean geometry. For 9.7 we have two sums, three sums. Alright, so it's going to make that a bit smaller. And that is smaller as well. Okay. So we're looking at number 8 of exercise 9.7. We are told two circles intersect at G. So if two circles intersect at G, two circles intersect at G and F. So there's no F here. Is there F in your textbook? Yes, okay. Sorry, E. Was there E in your textbook? Yes. Okay, not the E. Nice. Now we are told that CD P is a tangent. Even if CDP is a tangent, what do we know? We know that D4 is equal to G3. Not so. G3 is of course equal to that, if needed. But it's not marked, so majority of the time if it's not marked, it's of no significance to us. Okay. Then we're told that DG is a tangent to the smaller circle at G. The DG is a tangent to the smaller circle at G. So if this is a tangent, what do we know? We know that G2 is equal to A2. Why? Tan chord theorem. Okay. Then we are told that AED and AGF are double chords. AB produce and GE produce meet at C. Then we are told that VE is drawn. Prove that. So we need to prove that AGF is parallel to CD. AGF, this line is parallel to CD. People, if these lines were parallel, then alternate angles would have been equal. So that angle would have been equal here. So if I can prove that, I've done the job. Not so. Alternatively, here's another angle that is marked here. That if we can prove that angle is equal to this angle, the job is also done. And I think that is the retail part. So there's a dot, and then it's easier to prove that one. Okay. You all see that, people? So where do we start? We start by letting one of those angles that we indicated be X. So I go with D1. So I say let angle D1 equal X. So if that is equal to X, which other angle is equal to X? G2. So G2 is equal to X. Why? Tan chord theorem. Okay. So G2 is X, A2 is X. Why? Tan chord theorem again. Since, yes, D1 is equal to A2 is equal to X. Therefore, AF is parallel to CD. Why? Corresponding. So that the Z. Oh, you say it's not corresponding. Alternate angles are? Oh, you say converse. Sorry, converse of alternate angles are correct. Yeah. We're proving that the lines are parallel. To prove that lines are parallel, alternate angles, we prove it by using alternate angles are equal, corresponding angles are equal, or co-interior angles supplementary. That's what we do. Okay. Because if you look at it, these angles are alternate, but are they equal? No. The only time that alternate angles will be equal if the lines are parallel. Okay. So if these angles are equal, indeed those lines has to be parallel. Okay, that's what I'm asking. Alright, so what I do is I now put that on the diagram so that for future calculations, if needed, I can go with that thing. Again, if we didn't prove that these lines are actually parallel, you can still enter it onto the diagram and use it in the next calculation if needed. Okay, just in case you don't manage to prove that. Okay, I'm just taking this off as I want to keep the diagram in focus. Let's go with B. Though let's talk in the background. Please stop it, no? Don't mind. Here we are told that CD is a tangent. CD CD is a tangent. CD is a tangent to circle BCE. Oh, there is the E, there's no. Sorry, I erased the E, man. Sorry, I was looking now, where is this? Okay, so people, for us to prove that CD is a tangent to circle CBE. So we take one step back. We say, if this was a tangent to the circle, then what would we have known? C2 is equal to B1. Why? Tangent theory. So for us to prove that that is actually a tangent to the circle, I'm going to prove that B1 is equal to angle C. Okay? C2. So where do I start? You can say let B1 equal. Am I going to use X again? No. We're going to use Y. Why? Otherwise, if you use that to be X, and that means to say you're automatically making those angles the same. So we say let angle B1 equal Y. So if B1 is equal to Y, which other angle is equal to Y? Remember, what is this? Cyclic one. So the exterior angle is equal to the interior opposite. Can you see that? So G1 is Y. Reason? Exterior angle of cyclic one. So if this is equal to Y, which other angle is equal to Y? C to Y. Alternate angles. Okay. So angle C2 is equal to Y. So alternate angles with AF being parallel to CP. So now clearly there we can see that the angles are equal. No? So we say since B1 is equal to C2, which is equal to 1. Therefore, CP is a tangent to circle through BCE. Why? The converse of the tan chord theorem. Or angle between line and chord equals angle in the alternate segment. That is the wording here. But writing converse of tan chord theorem, 4 marks anyway. Okay. Now you remember that these points here is actually concyclic, or a circle can be drawn through those. Okay. I don't want to populate the diagram too much because the diagram is a lot missed and becomes difficult to solve. Okay, to see things on the diagram. People will be looking at C. Question C says prove that DG is equal to DF. Now if David said take a step back. If DG is equal to DF, Then what can we conclude? G3 has to be equal to angle F. Why? Angles opposite equal sides. So what I'm going to do is I'm going to actually work in reverse and see if I can prove that. Okay. Right. Let G3 is. But we know what G3 is in terms of X and Y. What is G3? This is angles on the straight line. So instead of introducing another variable, I'd rather say that G3 is going to be 180 minus X plus 1. So if we can prove that F is also 180 minus X plus Y, I've done the job. You see that? So, and why is that 180 minus X plus Y? It's angles on the straight. That is 180 minus X plus Y. Or you could have written it as 180 minus X minus Y. So I need to prove that F is also 180 minus X plus Y. Right, how are we going to do that? D4 is going to be D4 is 180 minus X plus Y. Why? Tan cos theorem. Can you all see that? This angle and this angle is the same. You remember this is a tangent and there's your triangle. So there's your tan cos theorem. Okay? So D4 is equal to 180 minus X plus Y. Tan cos theorem. 180 minus X plus Y. And then Y? Alternative, as you can see there. Okay. So angle F is going to be 180 minus X plus Y. The reason? Alternate angles with AF being parallel to. Now what can we say? We have enough now to conclude. Since angle F is equal to G3 equal to 180 minus X plus 1. Therefore, DG is equal to FP. Why? DF. Why?
Angles opposite.
The sides opposite equal angle. Remember that the angles was equal here. Okay, so it's going to be sides opposite equal angles. Okay. Any questions? How many marks for something like this? There's already 4 or 5 marks here. The previous 2 sums, probably 4 each. So with that diagram already 16 marks. Okay. Please look at number 4. Please settle down if you don't mind. Number 9. In number 9, we are told DC is a tangent to the circle center O. So if BC is a tangent, then what do we know? That B3 is equal to A1. Did you see that? Why? Tan cos theorem. Then we are told O is the center of the circle. So what do we know from here? O1 is double D1. Angular center is twice angular circumference. Then we are told that chord BA is equal to BC. So what can be concluded there? Angle C is equal to A1. So all this have the same. So okay, now that has the same marking. So what does that mean? DB is equal to DC. Why? Sides opposite, equal angles. Then we are told that AC is drawn to cut the circle at D. Then we are told that OA, BO and DB are drawn. Let angle C be X. So there's X, 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 and so on. Okay. The first question, prove that BD is equal. We did it already. No? Too easy. Right, so let's go. So where do we start? We say, since C is X, do I have to say let angle C be X? No, because that's given to us. Which other angle is equal to X? A1. So angle A1 is X. Why? Angles opposite equal sides. Right, now what? B3. Why? Tan 14. Okay. Now, since B3 is equal to angle C, which is equal to X, therefore, sorry, DB is equal to CD. Why? Sides opposite. Okay, we'll carry on tomorrow with this, okay? Okay, good afternoon, class. So, yesterday we got to a point where I think the bell rang. Then we didn't finish this question. Eh? Yep. So just to refresh our memory, what is given so far? DC is a tangent to the circle at center O. Then we are told that chords AB is equal to BC. AC is drawn to cut circle at D. Then we are told that OA, OB and DB are drawn. Let angle CBX. Prove that. So we have proved that already. We've done A already, not so. So we proved that DB is equal to DC. Okay. Right, so everything that was calculated is now on the diagram. Okay. So let's look at B. B asks you to write A1. Write A1 in terms of X, showing all working and showing all working steps and give all reasons. Okay, so if you look at where O1 lies, O1 is here. But we know there's a relationship that is existing between O1 and D1. Why? Angle at center is twice angle at circumference. So D1 is actually equal to X plus X. Why? Exterior angle of triangle. You see that, people? So, we know that angle D1 is equal to 2x. Exterior angle of triangle, dot, 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 and this triangle, DBC. That is now 2x. A1 is the angle at center, is twice angle at circumference. Okay? So what do we say? Angle O1 is equal to 4x. Angle at center equals 2 times angle at circumference. Okay, and there we got 4x. Let's look at, is there a C? No. Right, so let's go to the next question. Question 10. Right, for question 10. Okay, this is a bit smaller. Right, so in question 10 we are told that PA and PB are tangents. People, if PA and PB are tangents, what do we know? We know A1 is 90. Oh yeah, this is now your radius as well, no? That's your center. And then B1 is 90. Why? Radius perpendicular to tangent. So what can we say about this here? Cyclic quad. Why? Opposite angles are supplementary. Okay, then we are told that the angle D is 55. We also know there's a relationship that exists between that angle and this angle. This must double. Then of course we can calculate this angle here. Why? Sum of angles in the quad. No? It's 360. So, we are told that D is 55. Oh my word. So easy. They asked us to prove that okay. We have proved that AOBP is a cyclic quad. Right, so where do we start? We start by saying angle A1 is equal to 90 degrees. Why? Radius perpendicular to tangent. Then angle B1 is equal to 90y. Radius perpendicular to tangent. Okay. So since we state the obvious, A1 plus B1 is equal to 180. Why? Opposite angles of cyclic. No, opposite angles supplementary. Opposite angles supplementary. People, we can't say it's a cyclic quad, so we're proving it's a cyclic quad. Okay, opposite angles supplementary. Therefore, no, I'm messing this up here, no? Sorry. Therefore, AOBP is a cyclic quad. People, if you had written that reason there, you lose that mark, no? The conclusion mark. And why is it a cyclic quad? Because the opposite angles are supplementary. Here we go. As I said, if you had written that there, you lose the mark. Okay. Let's look at B. The B part of the question says calculate the size of angle P. Calculate the size of angle P. But have we indicated already? Angle P. So if we got O1, we can go with the sum of angles in the quad. But we know that O1 is equal to 110 degrees. As you can see, angle at center is twice angle at circumference. Angle at center is equal to 2 times angle and circumference.
So can we also do supplementary?
Sorry?
Supplementary.
This one and this one, yeah? We are going to do that. Oh yeah, you could do that. Once we got a 1. Is that what you're saying? Yeah. So she's saying instead of getting sum of angles in a quad, because this is a cyclic quad, opposite angles are supplementary. So angle P is equal to 180 minus 110 degrees, opposite angles of cyclic quad. Remember, all cyclic properties at this stage are now evident in that quad. Please give you an answer, 70 degrees. Okay. Right, so that basically brings us to the end of exercise 9.7. Okay.